Okay, so solving systems by graphing guided notes. The whole point of why we started with slope is because you guys are going to have to understand the slope-intercept form and how to find slope on your graph in order to find the solution of a linear equation by graphing. So if I give you this slope-intercept form and this equation of slope-intercept form, and you graph both lines, where those lines intersect, that's going to be your solution of the system, okay? So all that I did on this first graph here, I found my line for y, so I did my -1 and y-intersect, and then I found the slope of that, so I went 1, 2 over 1, 1, 2 over 1, and then I grabbed my second line. My y-intercept was 5, so I went up to 5, and then I over 1, I kept going down all the way until the lines intersected. Where the lines intersected, then you just find the ordered pair. Ordered pair, you guys know, is x, y. So I start my origin, I went over 2, and then up 3. So my ordered pair 2, 3 is going to be the solution to that system. Okay? Now, it's not just that. We are going to definitely expand from that. So, looking at example number 1. The first parts of examples that we're going to do, there's going to be 3 examples. We're going to identify solutions of systems using a graph. So we're going to state the solution of the systems graphed below. All that means is we're going to find the ordered pair of where these 2 lines intersect one another. Where those 2 lines intersect one another, that's our solution, okay? So let's look at our first graph here. What's going to be the x value of where these 2 lines cross each other or intersect? What's our x? What's our x? Well, if we're starting here from the origin, so we're trying to come up with an ordered pair. So if we start at the origin, we're going to have to go over to the left 2. So my x value is -2. So then what's my y value going to be? 1. So the ordered pair, or the solution for the system graph below, is just -2, 1. Okay? So the things you need to remember. Ordered pair, you do your x value, then your y value. On your coordinate plane, your x value is your line that's horizontal. Your y value is vertical. You find your x first, then your y. Okay, let's take a look at the second graph. So again, you're going to determine where these points intercept. Now, what's kind of different about the point of intercept between these 2 points?
There's no dot.
Okay, so if there's no dot, let's go ahead and add one in there. So right where those 2 lines meet, let's go ahead and plot our point. Now, once we plot that point, what do we determine next?
It's in like the middle.
It's in the middle. So what's it in between? What numbers would it be in between?
1.5.
Yeah, so it'd be between, for my x value, it'd be between 1 and 0, right? So what's between 0 and 1? Half. So you can either put half or you can put 0.5. Okay? So my x value is 0.5. What's my y value going to be?
0.
No, how far up do I have to count up to get there?
3.
No, not 3.
1 and
2. So you're using your grid lines to count to determine the y value then.
Yeah.
You guys with me so far? Yes, no?
Yes.
Okay. All right. Let's look at the third example then. So example number C, what you guys told me the first time, where the lines intersect, there's no point. So we're going to go ahead and add that point in.
Oh, I got a question.
Yes, sir.
Did you say number C?
That's what I was
Letter C. Yeah, I did. That's where I'm at today, Chance. Okay? Okay. I'm really struggling, but I'm here, and that's what matters, right?
Yeah.
Okay. We'll keep doing number C right now, okay? Okay. Okay. Just for today. Okay. So, what do I find first? How do I find the solution to this set?
The intersection. You're gonna find where it intersects.
Where they intercept? Okay, and I did that. And then I determined the what of that point of intersection. What am I trying to find of this point now? The x and the y, the ordered pair. So what's my ordered pair going to be?
4.
4. And what's my y going to be?
1.
Close.
Negative.
-1. Good. Okay. So that's the first part. We have 2 more parts that we're going to go through. Maybe 3. Are you having your work so nobody looks off of it? Okay. Example number 2. Okay. So now we're given the ordered pair. But we have to determine if this ordered pair is a solution of the given system. So we have the given system. We have the ordered pair. I need to figure out if they work or not. How do you guys think that I'm going to determine if these work or not?
Plug it in.
Huh?
Plug it in.
Plug it in. Am I going to have to plug it in for one or both the systems? Both. Good. So what Chance means by plug it in, I'm assuming, correct me if I'm wrong, we're going to take this ordered pair and we're going to substitute it for this system to see if it works. And then we're going to use the same ordered pair and substitute it for this system to see if it works. If they both work, is it a solution? Yeah. What if one of them doesn't work? Will it be a solution then?
Then no.
No. So it's all or nothing, right? So here we go. So for x, what do I substitute?
2.
Okay. And I'm using my first. What do I substitute for y?
Negative 2.
And that equals 4. So we're going to go ahead and solve. So now we're not solving per se. We're just simplifying. What do we want this left side to equal? 4. Okay. So order of operations, where do I start? So do you guys see how all these prior skills are building into it now? So now we're talking about simplifying and order of operations from Unit 5. So where would I start for order of operations?
3 minus 2.
Which equals?
6.
So now I have 6 minus 2 equals 4. What's 6 minus 2?
4.
Does that work out?
Yes.
Yep. I put a check to say that it works, okay? You don't have to do that. That's just, again, a cue for me to remind myself that it works. That's not our final answer, so no. Because our final answer is going to be if it's a solution or not. Okay, so now we've got to look at our second system and see if this ordered pair is a solution for it as well. So again, what do I substitute for x? So I'm going to write 2 minus 3. Ooh, I can't keep. Minus 3 times negative 2 equals negative 4. Okay. All right, where do I start with this? How do I start simplifying my left side here?
2 minus 3.
No, order of operations. PEMDAS, remember? Do you see any parentheses? Yeah, but not a group of numbers in parentheses. Do I see any exponents? No. Any multiplication?
Be negative 3 minus 2 or times negative 2.
Okay, so what's negative 3 times negative 2?
6.
So I have 2 plus 6 equals negative 4. So what's 2 plus 6? 8. So is this a solution? No. So we just come up here. We would put no, and then this is where you would box it. Okay, because that would be your final answer. Questions?
So
Okay.
we do have to box.
Your final answer, yeah. Okay. Just because that's a lot of work there, right? I want to be able to easily locate your final answer. Now, let's say that you missed it and you put yes. Well, that would draw my eyes there. Then I could go down and check your work from there. Okay, so we're going to do the same steps for the next two to tell if they're solutions or not. So this time I'm using the ordered pair negative 1, 5 to see if each of these two if it ends up being a solution. So when I go to rewrite it, substituting for my x and y, what would I rewrite it? What should it look like? Let's have Ben tell me.
Huh?
So when I go to rewrite this,
I just put negative parentheses negative 1 plus 5 equals 6.
okay, and then go ahead and simplify that side of the expression.
It would be 1 plus 5 5 equals 6.
And what's 1 plus 5?
6.
So does 6 equal 6?
Yep.
Yeah. Okay. Josh, do the bottom one for me, please.
You do 2 and then parentheses, put -1, and then plus 3 and parentheses 5 equals 13.
Okay, go ahead and solve.
You take 2 times -1, which is -2, and 3 times 5, which is 15. And then, and then you minus 15 by by 2.
So does this work out?
Yeah.
Yeah. So this ordered pair is actually a solution for the given set. So we're going to put a yes and box it. So what I'm going to be looking for on your homework and on your quizzes and on your tests is that you're actually going through, you're substituting, and then you're simplifying each side, and then that you're showing that they're either equal or not equal, and then tell me if they're a solution or not. Okay? Okay. Example 3. Maddie?
So you would do parentheses 3, then 1, minus parentheses -1.
Wait, hold up. So we're going to do our first one right up here, right? So I have, you substituted for x with your 3, minus, what comes next? 2, and then what?
Equals
Then your parentheses, because we're going to substitute for y. What do I substitute for y?
-1.
-1. Good. Then your equals 7. Okay? Oh, 5. Sorry.
Yeah.
Thank you. See, you and I, we're in this together. Now what do I do?
You do -2 times 1, the -1,
Which would equal?
3.
So I have 3 minus 3 equals 5. What's 3 minus 3?
0.
So 0 equals 5. So is this going to be a solution?
Wait, would that be 2? Because it would be 2 times negative.
Oh, yeah.
Sorry, I messed up.
No, I'm messing up with you. We're a team.
So it'd be
Way to catch yourself.
positive 2.
Okay.
Equals 5.
Oh, so far it is a solution. Yeah? Okay. Nice job catching yourself. Okay. Let's hear from Hannah.
What? 2 times 3, 3 in parentheses, minus -1 in parentheses equals 7.
Okay.
Am I solving?
I would like you to.
2 times 3, 6,
Okay.
minus
So basically, you could think it as a -1 times a -1, or a negative times a negative, which will be a,
positive
okay.
1 equals 7. 6 plus 1 is 7, 7 equals 7.
So is this a system?
Yes.
Yeah. A solution to the system, sorry. Yes. Good job. Any questions? How do we feel about it so far? Thumbs up if we're golden, thumbs down. If we're not, thumbs in the middle if we're okay at this point. Okay. All right. Give Hannah a second to write this down since I was calling on her here. Okay. So now, this is where it gets to be fun, you guys. So we're going to take example 1 and example 2, and we're going to put them together. Before we do that, just a quick reminder. Hooyvuks, you have Hoy, that's your horizontal line. It has a 0 slope, so y equals a number. For a vertical line, it's going to be an undefined slope, and then x is going to equal a number. Okay, so example 3, solving systems by graphing. So what we're going to take, we don't know what the ordered pair is, do we? Josh, do you have an idea?
No, I was going to ask if we could go over the example 1s again.
Yes, in just a moment.
Before we combine them, because I don't understand those.
Example 1s.
Why did we miss
how about we go through this, and if it doesn't click, we'll go back to 1. But I think bringing them together, it'll click a little bit. What do you see about how these equations are written? What did we learn last week?
They're written in MX plus B.
Yeah, they're written in slope-intercept form. So y equals mx plus b. So we are going to graph this line. Then we're going to graph this line. Then we're going to find where those points or those lines intersect. That's why it's going to be super important that when you graph your lines that you're going to use a ruler. And also, referring back to what I said during the opener, some of you guys were already doing your 3 points, plotting out those 3 points. I want you to do this for this, okay? All right, so the first thing I'm going to do is graph my first system. So y equals negative 2x minus 1. What's my y-intercept? What's my y-intercept? So I start at my origin. I'm going to graph that negative 1 on my y-axis, right? Then the slope is going to be what? So I'm going to go down 2 over 1, correct? Now, in order to make your line more accurate, we're going to come back to this point. How can I graph the slope on the left side from this point? So if my slope was negative 2 over 1 and I graphed it to the right, I kept it negative 2 over the 1. If I want to graph to the left, do you guys remember how we're going to do that? Yeah, we're basically going to move that negative down. So we're going to go up 2 over 1. Okay, and that's going to help us get a more accurate line. So then when you draw your line, make sure you draw it through the whole entire coordinate plane. Make sure that this is where it's going to be real important that those lines go right through those points that you plot. Yeah, absolutely. Anybody else like a ruler? Uh-huh.
Does that look off to you?
Looks completely off to me.
Because you went up 3.
Okay.
So 1, 2 over 1.
Okay.
Okay?
Yeah.
Okay. So now we're going to look at our second line. So I have y equals x plus 5. So what's my y-intercept? What's my y-intercept? 5. So I start at my origin, I go up 5. I plot my point. The slope is a variable x by itself, which means the slope is what? 1 over 1. So I have 1 over 1. Okay? So from here, I'm going to do up 1 over 1. Now I want 3 points, right? So instead of going up 1 over 1, I would do the opposite. What would I do here? Down. There we go. And then we're going to graph this line. Oh, that line's way too thick. Let's fix that. There we go. Okay. Now, what we need to find is where do these two lines intersect one another? Where do they cross? Bless you. Where do they cross?
3 over 2.
Okay, right there. So this is where we come up with our ordered pair. What's our ordered pair? What's my x value going to be? And then my y value?
3.
3. Good. Now, is there a way to check that?
Probably.
Yeah. How do you think you... Probably. You know it. So this is going to be our answer because all it asks us to solve the system by graphing. We graphed it. We solved it. Now, what if you're like, I just don't know. I just feel like something's off. Well, how would you check it? What could you do?
Do it opposite. Does that work?
How about...
Like go down instead of up or something?
No. How about you just substitute for your x and y's to see if they equal? Could you substitute those numbers in?
That too.
Yeah, yeah, I guess we could do that too. Okay, let's look at the next example though. I'm not going to make you do all that. Okay, so our next example, we have y equals 13x minus 3. So we're going to go ahead and start by finding that line on our coordinate plane. So I start by determining what the y-intercept is. What's my y-intercept?
What?
So I'm right here.
Number 3.
We're looking at this system.
Where?
So
Yeah, I have 1 over 3x.
I do too. Yeah, so do I.
okay, let's fix that. Thank you guys. When I cut and pasted it, must have not carried it. Thank you. Okay, so what's my y-intercept?
1 over 3.
Oh, my y-intercept?
It's negative
3. So I go up or down on the y-axis?
down.
Down to 3, okay. And then the slope is?
1 over 3.
So up 1 over 1, 2, 3. And then how do I find my other point that I want to plot?
Go back the opposite.
Down 1.
Negative 3.
Good.
And then keep going like on both.
You don't have to keep going. My requirement is that you have 3 points, okay?
I just keep going.
If you want to keep going, you are more than welcome to do that. I'm not going to say, oh, Josh, you're going to lose points for doing that. It's totally fine, okay? Okay. Now, what's the problem with how this second equation is written?
It's not in y equals it's supposed to be.
Yeah, it's not in slope-intercept form. So because it's not in slope-intercept form, what do we have the privilege of doing?
Putting it in slope intercept.
Okay, slope-intercept form, which variable is by itself?
Y.
The y. So my goal, oh, Miss Lidikin, here we are, solving equations, kind of. My goal is to get that y by itself. So I'm going to circle that y because that's going to be my reminder that I want to get that y by itself. Okay, I need you to set up. And we're back here, okay? Right here. And then okay, so if I want to get that y by itself, what do I have to get rid of?
I figured it's not well.
Huh? The 2x. How do I get rid of the 2x? Minus 2x. Whatever I do to one side, I do to the other side. Now this one's a pretty easy one, right?
Yeah, you just
So this one I can write y equals, now, beginning of the year, I told you, what do I always want written first?
2 or the x.
The variable, right? So we're going to put negative 2x, what?
Oh, plus 4.
Plus 4. There's our slope-intercept form. So from here I can go ahead and graph this line. So what is the y-intercept?
4.
4. And then the slope,
Negative 2 over 1.
and then I go back to the 4 and do the opposite, right? So positive 2 over negative 1,
And it intersects.
and it intersects. Now, do you think it intersects every single time? Do you think it will?
No. What do you think?
Do you think that when we go to solve systems of equations by graphing that your lines will always intersect?
No, if it doesn't intersect, it's wrong, right?
Well,
But it's like
not necessarily, but what kind of lines wouldn't intersect?
Non-intersecting.
That is an excellent answer. What kind of lines never intersect?
Point, but opposites.
Nope. Okay, kind of, but what are those lines? Yeah, there it is. There it is. Okay, so parallel. Okay, so we know where these lines intersect here. What's going to be the ordered pair? What's the solution to this system? What's my x value?
3.
And my y?
Negative 2.
You guys all agree?
How did you find that out? What? Because it's hard to intersect.
Yes. And that's, Josh, that's all we did on the first examples. Okay? How do we feel about it?
Fantastic.
Okay. If you guys are understanding something, you have got to tell me because I can't enter into your little minds and see what you're thinking, which is probably a good thing most of the time, right? But for the sake of understanding. Okay. Here we go. So, looking at this next example problem, what do I need to do first?
Put it in slope intercept form.
Put it in slope-intercept form. So I have negative 2x plus 3y equals 6. So if I'm going to put it in slope-intercept form, which variable do I want to get by itself? I want to get the y by itself. So what do I need to get rid of first? Now?
The 2x.
How do I do that, Emily?
Add on both sides.
Nice. So now I have 3y equals, and as you guys told me already, we're going to put our number with our variable first, plus 6. Okay, my y is still not by itself. What do I get rid of next?
Divide by 3.
Okay, I'm going to divide by 3. Now if I divide one side by 3, I'm going to divide the entire other side by 3. Okay? So can I take 2 and divide it by 3 and get a whole number? No, so I'm just going to leave that as a fraction. So I'm going to have it as 2 over 3x. And then what's positive 6 divided by 3?
2.
Positive 2. Okay. Did I lose anybody there? Okay. So the next step that I'm going to do is I'm going to graph this line. So I go to my my coordinate plane. I start at the origin, and I'm going to graph the y-intercept on the y-axis. So which direction do I go? Up 2. Plot my point. Okay. Then the slope of this line is going to be so up 2 over 3. And then to get my second point, I'm going to do the opposite. So down 2, left 3. Ooh, that was so not okay to look in. Down 2, 1, 2, 3. There we go. Now I'm going to plot my line. Okay. You laughing at my arrows? Okay, now, can I take x equals 3 and write it
No.
as a system?
No.
No. Can I plot and draw a line that represents x equals 3? Okay, so where would I plot the point for x equals 3? On which axis? Yeah, so that x equals 3, I just plot the point on x. Now, if you go back up to your notes, when it's x equals a number, what kind of line am I going to have?
Vertical.
I'm going to have a vertical. So when it's x equals a number, I'm going to have a vertical line. So my line,
That's intersects.
oh no, it intersects.
Yeah, I said that.
Oh, okay. So it's going to intersect right. Oh, that's off.
Okay, cool.
My lines are not wanting to be my friend. I wish I had like a ruler. There we go. Okay. Where does this point intersect at? What's the solution going to be?
Up 4.
No. The ordered pair. We want the ordered pair where these two lines intersect. So what's my x value? Remember, ordered pair is x, y. So what's my x value?
3.
And then my y value? No, what's my y value?
Oh,
4. Does anybody have a question on that one? Does anybody need further clarification of where we found that it was the vertical line? Okay. Hey, Chance, Hannah, can you guys set your head up for me, please? Okay. So, the last example. We at this point know that neither one of these can be written in slope-intercept form. We already know that when we graph x equals -2, or when x equals a number, we're going to have a vertical line. So when we graph a y equals a number, according to our mnemonic device at the top of the notes here, what kind of line am I going to have when I graph a y equals a number? Even, or left to right. Vertical. Good. Okay, so x equals -2. Where do I graph that -2? On the x-axis. So I have my -2, and I'm going to graph my line. As you guys should be graphing your line. You guys graphing your line?
Yeah.
Do your lines look as nice as mine?
No.
I already did that.
Okay. Then we have y equals 5. So where do I plot that 5?
On the y-axis.
Okay, on the y-axis. And what kind of line am I going to have for this one?
Parallel.
Not a parallel.
Or, what's the word?
I don't know.
Vertical.
Vert. Horizontal, yeah. I was listening to Dylan back there, but Ben came up and saved the day. Okay, where do these two lines intersect?
-2 and 5.
-2 and 5.
Y'all agree?
Yes.
So the solution to this set is -2 and 5.
We're on.
You all right? Okay. Flip it over. No, did you say no? This is the last part. Special cases, okay? So Chance already told us, and we already talked about, there's going to be times where your lines don't intersect, and those are going to be called special cases. So an example of lines that don't intersect are going to be parallel lines or coinciding lines, lines that are on top of one another, okay? So parallel lines and coinciding lines, they're not going to have a solution. They're not going to have an ordered pair, okay? So let's look at our last three examples here. Okay, so we have, I was nice to you on this first example, right? They're already written in slope-intercept form. So slope-intercept form, I have -4x plus 5. Hannah, go ahead and graph this slope for me, or the line.
Start at 5.
Okay? I'm assuming you mean on the y-axis?
Yes.
Okay, then what?
Go down 4. And then over 1 to the right.
Okay, and then start back at my y-intercept and do what?
I guess go up 4 and then go left, right. I mean left to 1.
There we go. 1, 2, 3, 4, over 1.
Oh yeah, they don't intersect.
Do you think it's just a Tuesday that everyone's just kind of struggling a little bit because it's Tuesday? Usually it's a Monday struggle, right? Okay. And then for my next one, let's have Riley. You've been super quiet back there.
Start -6.
Okay, so I go down -6, and then the slope.
I wouldn't go up,
Nope, I go what? Negative is going to be,
down, but you
okay.
can go down.
See, like that.
You have just enough room. You have just enough. You should. Do you guys have -10 on your graphs?
Yeah.
Oh, yeah, you have just enough. So -4 over 1. It's going to be that last grid line. Then you do the opposite 1, 2, from your,
You go up 4 over 1.
good. What kind of lines am I going to end up with?
Parallel.
Parallel. So you can just write parallel lines. Or you can just okay. Good. Or no solution to. Okay, let's look at the next one. So we have the first one that's already in slope-intercept form. Let's go ahead and graph that for me, Chance. Right here. So you're going to graph that slope for me.
Second problem.
Or graph that line for me, not the slope, sorry.
Okay.
Okay, so,
Which one? Negative. This one?
so my y-intercept is what?
5.
5. Okay, so, oop, I did not mean to do that.
5.
Wake up. Okay, and then my slope from that y-intercept is,
2 over 1.
so 1, 2 over 1. And then to get my third plot, 1, 2 over 1. I do it backwards. What kind of line do you guys think we're going to get this time if you just had to guess?
Even.
I don't even have 2 lines.
Clean.
Coinciding?
Yeah.
Okay, what do we have to do to this equation on the bottom here?
Y or simple form.
Slope-intercept form.
Form, but then you get the same answer, same problem. That's all.
Are you sure? Let's see. So, oh, how do I get the y by itself?
Plus 4x,
Plus 4x.
and then you would write it all down again.
Okay, then what?
Divide by 2.
Divide by 2 on
So
both.
you get y equals 2x plus 5.
Oh,
Yeah,
it is the exact same, isn't it?
that's what I was saying.
So if it's exact same, and we go to plot this line again, what kind of line is it going to be?
Same.
What Dylan just said.
Word, I can't.
The C one, coinciding. Coinciding, so you can
You
just,
said I was wrong.
I did?
Yeah.
Did I?
Yeah.
I said it's
Oh.
5 plus 6 plus 5. You said, well,
Oh no, I wanted you to show us. Hey, we've all made some mistakes today, so I think that we need to show all of our work. That way, if somebody makes a mistake, hopefully somebody else will catch it, right?
Because I was like looking over and I'm like, I swear I did it right.
Okay, let's do this third one here. Last one, guys. You've done a great job. Oh, I'm sorry. What do we have to do to both of these systems this time? Slope-intercept form.
I just don't like that they only give the switch sign.
Oh, because there's a lot of negatives there.
It's like negative 2y and
Okay, how do we get the x by itself?
not like that handle.
Or excuse me, how do we get the y by itself?
Plus
Plus x. So I rewrite my equation, which will be negative 2y equals x plus 2. Then I get the y by itself by doing what?
dividing by negative
By dividing by negative 2. So y is going to equal,
2. Negative 2x.
now wait, not negative 2x. Because my 2 is not on top, is it? My 2 has to stay on the bottom, right? So basically I have this.
So 1 over 2.
There we go. Okay, and then positive 2 divided by negative 2 equals a,
So negative 2.
positive 2 divided by a negative 2 equals a,
Negative
negative what? What's 2 divided by 2?
1.
1, there we go. Okay,
The 1/2 be 1 over negative 2.
oh yeah. It wouldn't be a negative 2, but it'd be a negative 1/2, right?
Yeah.
Good. Okay, let's graph this. So my slope-intercept, or excuse me, my y-intercept is going to be negative 1. Then my slope is negative 1 over 2. I'm going to graph my line. Any questions on how I'm graphing my line or how I got my plot, my points that I plotted on my line? Okay. Okay, now, let's look at our next one. So this time we have 2y plus x equals negative 2. I want to get the y by itself, so what do I do? How do I get the y by itself, Ben?
Well, y by itself, divide.
No. Can somebody help him?
Oh, minus x.
There we go, minus x.
Wrong problem.
That's okay. So now we have 2y equals Saved by the Bell.